बिस्मिल्लाहिर्रहमानिर्रहीम नहमदहू व नुसल्ली अला मुहम्मद रसूलुल्लाह करीम। ये प्रॉब्लम कॉम्प्लेक्स एनालिसिस के कॉची इंटीग्रल फार्मूले से रिलेटेड है। यूज़ कॉची इंटीग्रल फार्मूला टू एवेलुएट क्लोज लाइन इंटीग्रेशन z स्क्वायर प्लस 1 अपॉन z स्क्वायर माइनस 1 dz where c has radius 1 with the center at z is equal to 1. First of all, we should know about Cauchy integral formula. So I write here Cauchy integral formula. Let fz be an analytical function in a simply connected domain D enclosed by a rectifiable Jordan curve C, and let fz be continuous on C. Then fz naught is equal to 1 upon 2 pi I close in line integration fz upon z minus z dash dz, where z naught is any point of D. Here D is simply connected domain enclosed in rectifiable Jordan curve. Here this boundary is rectifiable Jordan curve C, and inside C this is domain represented by D, and z naught is any point in this domain inside D, and the property of fz is continuous on C, boundary of z on boundary of z. Then fz naught value of function at z naught is equal to 1 upon 2 pi I integration along C fz upon z minus z naught dz. Here z naught is this point which is inside D. So and fz, property of fz is analytic function in simply connected domain D. So we can write this as by multiplying 2 pi I on the left hand side, we get this integration fz upon z minus z naught dz is equal to 2 pi I fz naught. We have to find this type value in form of this. So we should first of all find z naught. For this we have to factorize denominator of this integrand. So we have to factorize in linear factor by this z minus dash plus 1 z minus 1 is 2 factor, and putting this value 0 and find the value of z which is equal to z is equal to minus 1 and z is equal to 1. This value we can write this value as close line integration z square plus 1 upon z square minus 1 dz as close in line integration z square plus 1 upon z square minus 1 we can write in linear factor as z plus 1 and z minus 1 dz. Now we must discuss about curve C. C is a circle of radius 1 with center z is equal to 1 on complex plane. So I plot trace this circle. It is real axis and it is imaginary axis y axis, and this is z plane and or complex plane or argand plane. We are given the C is a circle with center z is equal to 1. Z is equal to 1 is a real which is on the the x-axis on positive direction of length 1. This length is 1, so we can indicate this value is equal to z equal to 1. This point is z equal to 1. Also we indicate this point z equal to minus 1 on left hand side of x-axis of length 1. We get the point z is equal to 1. We want to here trace the C. C is a circle with center z is equal to 1. Z equal to 1 is center. It is center and radius is also 1. So this length is 1, which is radius, and center is this. So we can trace the circle. It is circle. Its center on the x-axis at a distance of 1 unit from origin, and you can indicate C as it is a closed curve, because here we are given starting and end point is same, so this is closed curve, and we have to find z naught here. What factor resemble with the z minus z naught, and what is function of fz we have to find here. For this we know that z naught is any point in any point of z. So z naught must be in C. Here C is this circle, and only z is equal to 1 point. Here in denominator, z equal to value of z is equal to minus 1 and plus 1. Only this value z is equal to 1 is inside C. Z naught is outside minus 1. So we can choose only z is equal to 1 is as z naught. Z naught is equal to 1. So for find this value, we can find first value of z naught. What fz? What value of fz can we find by changing this value as in this form or this form. So we have chosen z 1 as a z naught, so we can write this value as z minus 1, because z minus 1 is associated with z is equal to 1, because we find z equal to 1 with this factor z minus. So I write z minus 1 on denominator, and remaining factor will make fz. So for sake of apply Cauchy integral formula, so we take z plus 1 with this factor z square plus 1. So we can write z square this value as z square plus 1 upon z plus 1 dz. This is equal to this value of this integral. This integral is equal to this value, first, second, third. This and compare this value with Cauchy integral formula fz upon z minus z naught. We know that we here say we here see z naught is equal to 1 and fz is equal to this, because this is integration with respect to dz. So here fz is equal to z square plus 1 upon z plus 1, and z naught is equal to 1. So for applying Cauchy integral formula, we must find first the value of z naught, because z naught is equal to 1 and fz is also we find here. So put the value of z which is equal to 1, so I write here 1, z square 1 square 1 upon z plus 1, value of z is equal to 1 here. So 1 square 1, 1 plus 1 upon 1 plus 1 2, 2 upon which is equal to 1. Now we can apply this formula, which is nothing but Cauchy integral formula, which we study in this form, and we can apply this Cauchy integral formula in this form on transposing 2 pi I on the left hand side, and we get this value. So this integral which we change in this form, so this value becomes therefore closed line integration z square plus 1 upon z square minus 1 dz is equal to 2, this value becomes 2 pi I fz naught. But we have find value of fz naught here, which is equal to 1. So this integral is equal to 2 pi I. It is our answer. Thank you very much indeed for listening me. Wa akhiru da'wana alhamdulillahi rabbil alamin.